This is Geometry Unit 4, Lesson 6 on composition of transformation. The composition of transformations is a combination of two or more transformations where the second transformation transforms the image of the first one. Basically what that means is you do a transformation, take that answer, do another transformation, and you end up at a new image. So let's try this out. We have triangle ABC with these vertices, A, negative 1, negative 1, B is at negative 4, negative 1, C is at negative 5, negative 4. Draw a triangle A prime, B prime, C prime, the image of ABC after the transformation T8, 6. All right, what is T8, 6 again? It is a translation. And the 8, 6 means that you're going to move 8 to the right, so that would be x plus 8. And then 6 up, so that's going to be y plus 6. That's what you do to the coordinates. So each of the points are going to go 8 to the right and 6 up. So if we take A, 1, 2, 3, 4, 5, 6, 7, 8, and then 6 up. 1, 2, 3, 4, 5, 6. There's A prime, because that's what it said to label it. All right, B, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. There's B prime. And then C prime. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. And there is C prime. So when I draw my triangle, I draw it in red, there's my first transformation. And it happened to be a translation, so there's A prime, B prime, C prime, because that's what it said to name it. Then it says draw triangle A double prime, B double prime, C double prime, the image of triangle A prime, B prime, C prime after the transformation reflection in the x-axis. Okay, now first of all, know which ones you're translating. This says to take this one, which is the red triangle we just drew, and reflect it in the x-axis. So what happens when you reflect in the x-axis? The x stays the same, the y changes. And remember, it's perpendicular to the y-axis, or the x-axis. So 1, 2, 3, 4, 5 to the x-axis, 1, 2, 3, 4, 5 to the opposite side. So that will be A double prime. B, same thing, 1, 2, 3, 4, 5 to the x-axis, 1, 2, 3, 4, 5 to the opposite side of the x-axis, B double prime. Then C is 1, 2, 1, 2, there's C double prime, and I have created a composition of transformations to end up here. And notice my notation when I did these. I make sure that I label them correctly. This one is A prime, B prime, C prime. This one says take A prime, B prime, C prime, and make it become A double prime, B double prime, C double prime. And that's basically it. That's all you have to do for a composition. Now the notation of a composition is a little bit strange. Instead of telling you what one should do first, it uses a little composition symbol right here. That means composition, the little circle symbol there. So a composition means which one do we do first? Well, the way the composition is written, the second one right here is done first. So we do this one first. And then take that answer and do the other one. So the the composition that we just did, what did we do first on that composition? Well, on this first one, we did the translation. So we did that one first. So when we write this, this should be T8, 6 in composition with, we did a reflection of the x-axis. So this one says we do this one first, take that answer, and do this to it. So you read this, you read it right to left. All right, so it's always read right to left. Okay, not left to right. So you do this one first, then this one. So that's how you do a transformation, or composition transformation. Now, does it matter which one you do first? Well, let's find out. I want to do a rotation of 90 degrees in composition with a translation of negative 2, 3 on the point 2, 1. So according to our rule up here for composition, which one do we do first? We do this one first. Okay, now knowing your rules really helps when you do this. So let's start this out. I'm going to start at 2, 1. That's my starting point. Now, I'm going to do the translation first. So I'm going to put that here to show which one I'm doing. Translation of negative 2, 3. So I subtract 2 from the x and add 3 to the y. So 2 minus 2 is 0. 3 plus 1 is 4. All right, so that's my first transformation. Then I want to rotate that 90 degrees. Do you remember what the rule for rotate 90 degrees is? Remember, xy becomes negative yx. So if I take this point and I switch them and negate the y, so that becomes negative 4, 0. I end up at the point negative 4, 0. That's where 2, 1 ends up at the end of this composition. All right, now, what if I did the rotation first? All right, if I did the rotation 90 degrees and followed this rule, negative yx would be negative 1, 2. Then I want to do my translation of negative 2, 3. Negative 1 minus 2 is negative 3. 2 plus 3 is 5. Did I end up at the same place when I switched the composition around? No, I did not. All right, so this composition is not commutative. Order matters. So the order that you do the composition matters. Sometimes they will be. Sometimes they won't matter. But most of the time, the composition will not end up at the same place. Sometimes it will, but most of the time it will not. All right, now let's see if this composition is commutative or not. We have reflection on the y-axis and composition with a rotation of 90 degrees. Is that commutative? All right, my point A here is at 1, 2, 3, 4, 1, 2. All right, so this is, I want to see if this is commutative. So I have reflection on the y-axis in composition with a rotation of 90 degrees. And I want to do that on the point 4, 2. All right, so according to this composition, I have to do a rotation of 90 degrees first. All right, so rotation of 90 degrees, remember, is negative yx, so I'm going to rotate this 90 degrees. We go this way. All right, so that comes out to be negative 2, 4. So rotate this 90 degrees. 1, 2, 3, 4. There's A prime right there. Okay, now I want to then reflect that in the y-axis. All right, so I go 1, 2, 1, 2, and A double prime ends up there. So that puts me at the point 2, 4. All right, now what if I switch it around? What if I did the reflection of the y-axis first? Let me do this in a different color so we know which one we're doing. All right, so if I do the rotation of 90 degrees in composition and reflection in the y-axis, that's an R, sorry about that. So I start out with 4, 2, but this time I'm going to reflect it in the y-axis first. Okay, so if I take this one right here, reflect it in the y-axis, 1, 2, 3, 4, 1, 2, 3, 4, that would be A prime, and that ends up at negative 4, 2, and then I want to rotate that 90 degrees. Remember, rotation of 90 degrees is counterclockwise, so it's going to go down here. This becomes negative 2, negative 4. All right, so if I rotate this 90 degrees, it ends up down here at A double prime. So did I end up at the same place? No, I did not. If I did, they would end up at the same place no matter which I did this. So this is not, this composition is not commutative. All right, occasionally it will be, but most of the time it will not. So be very, very careful. Knowing your rules is very handy. All right, now let's see if we can figure out a composition of transformations that will take triangle BUG onto its image B prime, U prime, G prime. So basically we want to do two transformations or more that will actually make this match up with this. All right, now there's lots that you can actually do, but let's see if we can find 3 different ones. Okay, now what is one thing that definitely happened here? Well, it looks like that this slid over this way. Yeah. All right, so one way that we did this is we could have translated this how far to get it to line up. Let's see. If we want U to line up with U, let's see, we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, that matches right up where that is. All right, so that's actually a first step. It was a translation. How far did we go? We went 7 to the right. All right, so that would be 7 to the right would be T of 7, 0. Now, how do we get this to match up with this? This would be U prime, B prime, and then G prime. Oh yeah, I got the wrong one. This is B. This is U, and this is G. That's how they moved. Now, how do you get this to match up with this? What did you do? And then a reflection in the x-axis. Okay, so if I wrote that as a composition, one possible way you could have done this, what did we do first? We did the translation of 7, 0 in composition with reflection in the x-axis. So there's one possible transformation that we could have done. All right, now, how else could we have done this? Well, where else could we get this to line up? Well, what if we reflected this over the x-axis first? All right, so 1, 2, 1, 2, and that would be B, and then 1, 2, 1, 2, U, and then 1, 2, 3, 4, 5, 1, 2, 4, 5, there's G. And then how do we get this to line up with this? All right, how far do we have to slide it? 1, 2, 3, 4, 5, 6, 7. Oh, that worked. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we slid it again, so it's another translation. 7 to the right. All right, so that transformation, composition, we did the reflection in the x-axis in composition with a translation of 7, 0. So is this one actually commutative? Yeah, it actually is, so that works. Now, there's a lot of ways that you could do this. There's one more that we could do. What else could we do? Well, what if we did so that it lines up and then flip it on top of itself? So what if we did this? If we went, I'll do it in a different color so you see what I'm talking about. I'm getting B to match up with B prime. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. All right, so what if I translated 7 right and then 4 down? All right, for each point. What do I end up with? Well, B would end up there. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. U would end up there. And then G, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. G ends up there. How am I going to get this to flop onto this? Well, what am I reflecting over? I'm actually reflecting over this line right here. All right, and that line is reflected over the line y equals 2. So it flipped it on top of itself. So this transformation composition would be T of 7, negative 4, because that's 4 down, and composition with reflection over the line y equals 2. So there's lots of ways to get it to work. The best way to do it is the most obvious. There's dozens and dozens of ways. So be very careful on how you do this. All right, now the last one we're going to go over together in class. So hang on to that one. See if you can figure out what you would have to do to get that to work for the last one, which to look at this. Describe a composition of transformations under which the image of triangle ANT will be A prime, N prime, T prime. Basically, how are we going to get this to match up with this using transformations, or compositions of transformations? See if you can figure that out, and we'll talk about that tomorrow in class.